Okay, should be live. So, yeah, let's see. Let's see if we can get back to the speaker stuff. So to recap, the big missing incomplete thing is the safety system. So we know the algorithm we need to use. We have the data for at least one machine tested and proven working. We have a prototype daemon that does well, it's not complete yet, but it does the basic simulation of the speaker temperature. And the missing part is just making it all production ready. So the main thing is that right now the speaker safety daemon is basically runs on a capture PCM device, which is, as if it were an audio input. And that creates some problems because it ends up fixing the sample rate. So what we need is for the safety daemon to sort of be a secondary device, connected to a sort of secondary device that works such that it doesn't affect the operation of the regular speaker output. So it needs to sort of follow sample rate changes in the main output. It also needs to not keep the device awake, even if the device is it needs to not keep the amplifiers and the entire actual audio system awake. So it basically needs to be like a audio device that returns data when there is data, but otherwise doesn't actually have any influence on the system, which is probably going to need kernel changes. So I'm going to have to look into the ALSA subsystem in Linux and try to figure out how we're going to do that. So the first problem is going to be the sample rate stuff. So let me see. Just check a couple things here. I think we're good. So yeah, let's start digging through actually, the first thing we're going to do is add a bunch of debug to the ALSA code just to see what it's doing. And then we'll see how we can improve it. So first of all, I was working on the TSO stuff yesterday. That should be done. So let's call it speakers prod. Probably I think it's too long. So I'll make a branch for that. And I can close a bunch of this stuff that was for TSO. Definitely not going to need any ARM64 stuff or any file system stuff. Hopefully no include changes. We'll see about that, and no init. So drivers. Where is this Mac audio? Actually, it's in sound. So this is the top level driver for the everything on the Macs. And we will have to see how much can be done here, how much has to be done somewhere else. So the first thing I want to do is we have the Apple MCA. I'm going to add some prints when we turn the clocks on and the clocks off, because one thing I want to make sure is that the opening the secondary device doesn't actually turn anything on. It should just stay there waiting for the main device to turn on. So if I search for clock here, enable clocks. Print a clock enabled there. And here's the disable. So one thing we need to make sure is that that doesn't print when we open and close the secondary device with nothing on the primary. And that should mostly cover everything else. If we can get that to not print, then we're good, I think. Shouldn't keep anything else turned on. So now the question is, how does that sample rate stuff work? I actually don't know much about ALSA, about how this all kind of fits together. Povik is our audio guy, so I'm sure he knows more about how this all is supposed to work. And then there's all this like set of control stuff that we don't care about. That's going to come in later when we figure out how to make it safe as far as setting the volumes. But so this hardware param stuff might be interesting. We're basically going to have to trace a bunch of code to figure out where it's going. Because I have no idea how this works. Like how it works with multiple PCM devices that are sort of linked together. I know they have to have the matching sample rate, and something somewhere checks that. And I don't know how that works. So maybe do a little print here. And I probably want to get params rate. And then also on this one. So we have these substreams, right? Okay, so let's do a build on that. That didn't go very well. Because I don't have MCA there. Okay, so let's boot that. And I don't want the hypervisor for this because it'll mess with the timing. I want that. Yes, 314S, root weight. Shouldn't need any debug stuff for that. Which means I don't need that console. Okay. So let's open two consoles actually and just see what it's doing right now. Actually, multiple consoles. Let's do a demessage there. And on this one, for example, if I do an A record, so we want D, uppercase D. No, that's not right. Yeah, primary cap. Wait. Oh, I didn't enable the speakers. Hold on. Also, is this? I don't know if the VI sense stuff is even merged. This might be the wrong branch. Hold on. That might not be merged yet. Yeah, I think we don't have any of that merged. I should probably go to that branch, but I don't want to rebuild everything. I'll probably just rebase this if I can find. So that wasn't about 6.2. How do I rebase this? Get rebase. Keep forgetting how the syntax was for that. Yeah, so I think it's just rebase onto speakers prod-i. And we'll see how much of this rebase is, because this might be a little bit messy. Let's see how bad that is. What changed there? I don't know. Oh, port clock driver. Okay. Yeah, so that's port clock driver there. I think that's the only change. And then we drop the port started. Yeah, so we dropped that. And we added that. And then this one just goes away. Any other hits for port driver? No, I think that's fine. And there's more. And then in hardware free, we changed. What now? Nothing? Oh, no, this is just stuff added. Okay. So we keep that, just the clock stuff. And then we added things at the end there. I don't know if that's correct, but I guess we can try it. Yeah, I'm not sure if that's correct or not, but hold on. I think that's fine. Yeah, okay. I'll just keep that. Any other conflicts? No. Continue. Wait, what now? Oh, that's a fix-up. Where'd that sync gen and use go? I'm not sure what that is about. And what that did is this runtime PM stuff. Oh, it just changed. It's just the right L that is changing. Okay. I think that's okay. Fix sync gen, enable and NFV clock consumers. Now what? Oh, I think this is a botched rebase order. Yeah, I think this is just a botched rebase order. But that's okay. That's the only difference there. We keep that there. Except there. And then head experiments. What's going on here? Oh, it's just that. Okay. But that's already there, though. It's already fine in head. So we can just skip that. That's another empty one, which was... Yeah, that was one. I know that one's fixed. Okay. Yeah, we'll call this the branch then, ivsense. Let's see if that builds. At least I think it's... this only touched audio stuff, so it shouldn't force a full rebuild or anything. Well, it will because of the rebase, but it should be C-cached. So it shouldn't take forever. Yeah. Okay, there's some problems there. So we can find the... okay, almost there. Mac Audio, we have widget 764. It's not called capture widget. Yeah, that does sound like ADHD, which I also have. So you should get that checked out because I had the same problem, and there's no, magic fix for it, but medication helps a lot. So I am assuming this was a change somewhere. Yeah, it looks like it. Yeah. I think that's fine like that then, yeah. I think I can just auto fix up. Yeah, and that happens, of course it does. Is speakers okay? Yeah, that. Okay, that compiles. Let's get that. Reboot the computer. Okay. And now the entire audio system died. Right, because I need to pass the please blow up my speakers thing. Otherwise, with these patches, it doesn't. Wait, no, I also need to patch the device tree, don't I? Yeah. Oh, no, that's probably already here. Or something. Hold on, let's see. Yeah, okay, that's already commented out, so that's why I need the please blow up my speakers. That. The things we do to make sure nobody blows up their their speakers without asking for it. Okay. There, speaker sense. So that's what we want. Hardware 02. So if I do a record on that, and I just want to send it to dev null or something, and let's set the right format. C2. I think that should work. Yeah. Okay, so that looks like it didn't turn on the clock, so that's good. Yeah. So then let me just make sure that the volumes are not ridiculous, which right now they are. Yeah. Okay, so let's just turn the amp gains. I think if I just turn the amp gains all the way down, it will be not terrible for the purposes of speaker test. Still not safe, but I don't think I'm going to blow them up with a speaker test like that. Well, just in case, let's do a set them to -6 dB in here. I think that's okay. Oh, well, yeah, and then there's that. I need to fix. That's the other thing. There's a timeout thing. So that's a different thing I need to fix. Oh, and that's a problem if we can't kill it. Okay, that I need to fix. Yeah, okay, no, this whatever is not interruptible there needs to be made interruptible. So let's see if I can find that out first. Show, I think it's B for block tasks. No, W. So if I kill it and then show block tasks. Oh, okay. Then no. Then task states. Oh, but I can, oh, okay, I can do that. So it's just a record then trying to, if I control, oh. Okay, that's just Yeah, okay, that's not what I want. What I want is, can I make strays like something about the signals? Huh. Yeah, that's not what I want. Okay, hold on. Let's try that, and then so we get a SIGINT on read iframes. And then it's trying to do it again, which is not. Okay, wait, so does that mean that I can just do it twice? Oh, yeah, okay. Well, that's interesting. That kind of sounds like an A record bug. So if it gets a SIGINT, it should just quit. But okay, at least it's not hanging in the kernel or anything. So that's fine. We can deal with that. Okay, so if I let it time out, you get an EIO. So we need something for that. But also, let's see what happens if I do that. Oh, right. And what's the rate here? 8,000 hertz. Yeah, so that's the problem, right? We are blocking on the sample rate. Yeah, so that works. Oh, unmatched rate symmetry. Yeah, that's what I want. So I need to look at that. But also, it didn't print the clock enables. Oh, I forgot to stash apply, didn't I? Yeah. I'm just going to print. I'm just going to save these. Stop doing that. Okay. But, okay, this gives me somewhere to start looking here. Okay. Update symmetry. Apply symmetry. So that's the interesting stuff. Oh, and then there's a symmetric blah blah thing, right? Okay. Which probably is set somewhere here or here. Symmetric rate. Yes. So we're looking through all the DAIs. If it's not dummy, it does that. Oh, right. Never mind. So I'm kind of thinking of how we want to handle this. And actually, how it should look on the secondary side. Because one thing we could do is you open the device and it could do something like force you to close the device and reopen it whenever the rate changes. But the problem with that is it creates some weird race conditions. Ideally, like we need a way to a signal to user space that the rate has changed, but ideally in some way that the streaming doesn't stop. So one way to do that would be to return some kind of error from the when reading samples, and then you have to change the rate and try again. But I think that would cause it's too big a hammer. So maybe that's not a good idea. Because another thing I was thinking is we can just not tell the user space what the rate is, and it can just calculate it based on like the real-time clock, like the system monotonic clock, on how fast samples arrive. Because it also has to like simulate gaps, right? When streaming stops, it has to be able to simulate that streaming stopped and this much time elapsed and the speaker cooled down this much and then streaming started again. So we need some kind of control for that anyway. Basically, I'm not sure what the best way of doing this is. It might make sense to try to make it synchronous so that like it follows the rate changes by itself. And then we could just have like a property on the mixer that tells you the current rate, and it could just read that and change the parameters to match that. Okay. Let's look about that is dummy function is doing. Okay, that just checks for the driver. Oh, but actually, because this is checking for non-zero, one way to do it would be to actually just have the rate be 0 on the secondary device. And then this check wouldn't fire. That might work. Maybe we can somehow do that. So that's in sock PCM. Which means, okay, first of all, what happens if I do... hold on. Where's my Rust speakers? Here, speaker safety D, main RS. Oh yeah, and this was... Yeah, so what if I just set the sample rate to 0? Is that going to do something interesting? Like, is it going to guess? What is that going to do? Let's see. Let's find out. Asahi speaker safety D. Is that what it was? Yep. Okay, so set rate returns an E and val. Well, I can just trace it. Find out what the system call is for that. Oh, hardware refine? Or is it just the... Is it ALSA lib checking that? Oh yeah, it probably is just checking in software. I need libALSA. Oh, it's on GitHub now. I think it used to be in some other forge before. So is that try test? Does it refine? But refine didn't fail in that one though. So it does it. If hardware is interval var, which I think it is for the rate, file equals 0. parent and parent rate val dir. Okay. There is a value or and that sets a nearest. Is that right? Like, is that what they're supposed to mean? I guess. Okay. So I think it would be an interval, and then an interval, if it dir is less than 0, what is dir supposed to be, though? Rounding mode. Run top if dir is greater than 0, nearest if dir is equal to 0. Okay, yeah. Yeah, so that should be fine then. We're looking for nearest. Refine set I val. It does a check empty. How's this complicated? Okay. Do a set rate near. Otherwise, it's set rate. Is it because it's outside the driver specified hardware params, and so then the intersection is 0? What happens if I say rate 1? Should not be a special case. Strays and cargo is probably not a good idea. Yeah. I think it's probably getting the hardware params and then trying to refine it. Like, if I do that, that doesn't work. 8,000 does work, and then 8,001. Oh, that still doesn't work. Okay. Is that supposed to just set it to an exact rate? But then why is there a direction flag? Oh, to only contain one rate. Yeah. And then... Oh, wanted exact value is less, greater than, or equal to val following there. So, right. So it's if it's 0, if there's 0, then it's equal, and right. So set rate does a param set with that, and then that does param set. Refine set with val. And that sets both to val. But because this is only min and max, unless it's a mask. Okay, yeah, it's definitely an interval. So I think what must be happening is that something is checking back. Okay, so if I call that, and then I can see if it's literally... Yeah, so it prints that it does actually call the hardware, well, the kernel. and then it panics after that. But oh no, that returned E and val. Oh, okay. So it's both. It knows about the rate, and if I set to something like that. Right. So if I set it to something that is outside the range of the driver, it the user space side knows they won't work. If it is inside the range of the driver, then it complains when it tries to actually set the rate. Okay, so what we can do is just use a dummy rate, because I think what I'm going to do is have something so that the rate of a DAI tracks the rate of the main DAI, and though honestly, it should probably just turn off the symmetry on that link, because yeah, so on hardware params, it does that. And what we want is basically on update symmetry, yeah, symmetric makes sense for the that makes sense for the headphone jack, for example, right? But it doesn't make a lot of sense for the speaker stuff. So how? Yeah, I think I would just want to add another property that is like substring to RTD, runtime, has a DAI link, and the link. See, I don't even understand exactly what the architecture is here. So we have sound, link, named speaker, CPU is the MCA, the codec is okay, yeah. So that links the speakers, which is 2 MCAs to 6 speakers. And then the headphone jack is 2 to the codec. So does my audio deal with that? Yeah, it deals with the AI links. Symmetry gets called here in hardware params. And then this goes and sets all the, it calls all the backends and everything. Yeah, so I think we want some kind of flag. We want a flag that basically says don't check symmetry for this particular endpoint, and instead actually update the parameters on this one when the other one gets set. But now I want to know how the actual part where it's not even... Actually, no, it might be turning it on, yeah. It's just it doesn't get any data. So here are the links. Okay. So in this case, this takes the symmetric rate from the DAI and then also adds the driver. Okay, so symmetry and not that. So that should let me avoid the symmetry requirement. And then the interesting thing is going to be making it so we don't actually set that when we open the speaker's device. So let's try something like that. Let's go here and say follows rate equals 1. And then so I have my debugs there. I also want to print the rates somewhere. So you can see where that gets set. Sample rate, FE hardware params. Let's see. Samp rate. That might be okay. So yeah, this is definitely not going to work, but let's see how it fails. Compile that. Reboot. Actually, let me switch that to dev error. And then in apply symmetry, okay. So I think the way I'm going to do this is to just have the rate change automatically, and then the client side can just repeatedly query the rate as it reads data and update its own idea for the sample rate is that way. And then for the non-sampling times, I think we just have a timeout, and like if it doesn't get data in more than 1 second, it starts counting cooldown time. And the worst case, if there's a short blip and we don't account for that, it just means the estimate is going to be too high, which is fine. So that's probably the least intrusive way of doing it, I think. Oh, okay. And here's the trick with the ascents, right? If the front-end startup is skipped if it's ascents. Yes, I'll have to look at that also. Because maybe I can just avoid that here and not need the extra property I just added. Okay. Yeah, so it at least wants to have added right there. We can give it that. Also, did this save my settings? Yeah, it did. Okay, good. Okay, so now that doesn't work. Oh, still write symmetry. Okay. So, yeah, when we open that, we definitely... Oh, there's no 8,000 hertz? Okay. Oh, okay, yeah, probably because that's a bad rate for the codecs. Let's try 48. Okay, so that works as intended. And it does not enable the clock, so that's good. So we are correctly not keeping everything up. Okay, so it's still complaining about the symmetry. But probably because the direction is wrong. So if I do speaker test first. Okay, no wave files, I guess. No. Oh, interesting. So in this case, it is set rate. Oh, is it because the hardware already returns some rate? I think that's why. So you can do get rate max and get rate min. Yeah, let's try that just to add some prints here. This is not C. Okay. Oh, yeah. Yeah, so that gives us a rate range. And if it's already playing, then you get a single rate. That's fine, though. That's totally reasonable. That means we can just set the rate to the lowest sample rate supported, and then, yeah, that's fine. So then the issue is the other way around when the the symmetry on the other side, so when the speaker safety daemon runs first, it already sets the rate. Okay, so first of all, we need the isSense bypass here also. Actually, maybe that should be in the other one. Upstream params. Yeah, I think it should be in the DPCM. Yeah, let's do it here. So we can just take all those same things. So that at least should skip the extra stuff there for the codecs or whatever that is supposed to do. And then what sets CPU DAI rate? What about the AI active? Why is that? Oh, no, that's fine. That goes... Yeah, that never actually gets called because it's not active. So where... Okay, what's the path that sets the CPU DAI rate? And I just want to not set that. Yeah, so this is the part that's returning the hardware limits, right? It does the CPUs, and then it does the codecs. What's that DPCM merge rate thing? I'm not sure what that is. Doesn't that be hardware params fixup, which is interesting. We might be able to use that to set it to 0. Let's add some prints. Let's just see exactly what it's doing. It does have a name, okay. Okay, where is the hardware params here? Okay, let's just run this be copy parents for each PCM. Let's just make this debug. Oh, set DIA params. Okay, that's what we want. So that's what's setting it. And that gets called from... Oh, that gets called from Symmetry. Okay. Oh, no, that's just the dummy one. What about the actual ones? PCM clean. Codec DAI, codec params. CPU DAI. Okay, that's what sets that. So let's print the rate. Okay, so I think that's the interesting point. So where is the link stuff? The Symmetry is checking the RTD DAI link. It then calls this DAPM update DAI, and can we use that as a callback to like fix it up? So if we can, maybe that's the right call there. That one is that one. Update DAI. Takes a lock, calls that non-locked. That's widget, DI chan. No, probably not. I'm also going to enable debug here. So maybe I can just make that take the runtime. Well, honestly, follows channels and follows sample bits don't make any sense. because like changing the channel, you can't change the channels out from a consumer. Like, changing the rate makes sense. Changing the channels doesn't make any sense. But that means this constraint here is, and I'm not going to compile. I think we can just check that. Yeah, I think that's okay like that. And so then I should leave the rate unset on the CPU DAI until the other side comes in. Let's see if that actually works. And then I want to do this with debug. No early con anymore. Oh, right, I forgot to change the... It's a kernel, it's not printf. And so then the fun thing in the Rust side is going to be whether we can fetch the rate properly. Wait, did I mess that up again? Oh, there's more than one. So then the next thing to fix, if this works, is the timeout issue. Why did I choose Rust over C? What do you mean, for the safety daemon? Because it's a safety daemon, so we don't want a stupid bug to blow up your speakers. Makes a lot more sense in a safe language. Yep. I didn't enable debug, right? Yeah. And I need that again. Be lots of consoles. Okay. So let's add one more thing here. Let's go in main where it says sample rate foo, and let's just move that. And print it for everything. So grab that. Cargo run. So let's see how that goes. Interesting. So what that did for speaker sends no valid capture path. Okay. It does call the hardware params. Yeah, that's fine. Okay, so that did not work. Still checking the symmetry. Now it does work, though. Okay, one sec. I'm going to the toilet. Be right back. Okay, back. So where is the rate getting set here? Symmetry forces rate to 44,100. Well, that's is that right? That's right from when the speaker test plays, because it would do that. But the other way around, when I run the Rust side, run speaker test, Okay, so where... Oh, actually, if not RTD or or it doesn't follow rate, then that's fine. Okay, let's print that. And I'm actually going to say, I'm going to put a warn on there. So that way we'll get a backtrace. Actually, it's just, yeah, let's do it on 48K. And that way we'll see where that gets set on code path. Do I take concern to daily? Yes. Mostly, anyway. I skip days sometimes. Okay. Done that. Give me my consoles again. Message. Cargo, run that. And that should be enough to get us to see the warning. Yep. There it goes. Oh, that kind of got stuck. That's not great. Okay. Oh, wait. It actually faulted. Okay. I thought dev_air would work with null devs. I guess not. But at least now we know what path. Except I don't know what the rate is. Okay, I'm gonna have to fix that. Do we have a name? Yes, we do. Okay. Is it easy to get in Spain? I have no idea. I don't live in Spain. Sample rate bug. Yeah, there's... I mean, in this case, it's even weirder because we're doing something kind of funky. Yeah, just go away. Okay. So let's see if I can get that to do what I want. Okay, so set params rate 48K. Oh yeah, that's the dummy one that we don't care about. There's the CPU one. And that's coming from SOC PCM hardware params. Just what I thought it would come from. And why is it not taking the RTD from follows rate? Which I thought we had that. It says speaker sends. I think we support a few sample rates now. But I mean, we'll see what actually happens because there's a lot of things going on with the entire system. So if we run into issues, we'll debug them. Okay. Ah. Okay. So we have the link. Oh wait, that's. Oh, is it because of more than one? Because this is the backend. Okay. That does call the front end. But then it calls hardware params with the backend. But there is a fixup, which we might be able to use for this. And I get this past the backend. Maybe we can use that. The only trick is we probably want to check the yeah, B hardware params fix up in the link. So we can probably do that, but then we probably want to pass around the let's see. The stream type is what we're going to be missing. Where are the link stuff? Link things. Here. Link init exit. Oops. What is that doing? Well, that's in the platform driver. Oh, is it defaulting to that? Ah, okay, it grabs it from the driver. USB external monitors is being worked on. Okay, so then we need that in the driver, not in the link. And that's where... wasn't that in the driver? Okay, it's a subcomponent driver. Right, so there's no top-level driver here. So this is taking it from component driver, B, hardware params, fixup. So we don't have that, so it has to go in the link then. Okay, yeah, so that has to go in the link then. And then the tricky thing is going to be, how do I get the RTDDI link, name, and then state params. So sense should be PCM too, actually. Okay, let's just see what that prints. Actually, I want probably the stream name also. Okay. Okay, so what do we have? Do we have any calls to the fixup? Yes. No stream. I2S 0. Interesting. Why does MC I2S 0 go into the sense? I thought that was supposed to be... Oh, it's MC PCM, not I2S. Okay, yeah. Where does the I2S stuff get set? Oh, that's just the printf of the number of clusters. So that's just this one, yeah. And I guess it also does one because it's split into both. Okay, so the conflict is at the MCA I2S. Yeah. Yeah, I think we need the direction. Which means we're going to have to change that callback. Yeah, there's the string. So add that to the stream, and then we're going to have to add it to a ton of other places. comma. And then core. Need that from the driver. Where's that? Sock component. Okay. So now we're getting the callback, and it does say stream 1, which is what I want. Wonder if there's a better way of doing it, though. So we already have this DPCM hardware parent, so we get the substream. Maybe we can just set it here. Because that'll be a lot easier to fix instead of having to modify the params, which is kind of weird. Yeah, maybe that actually makes more sense. Maybe we can just overwrite it here and say we can, if we can check for the other if we can check for the other side and see if it's running. If it's not running, then we just clear the rate. Yeah, I think we can probably hack it all in Mac Audio, probably, and that'll be easier to upstream. And then we might not even need the follows thing. Yeah, because then it calls that with DPCM2, which is the sense, which is what we want. One second. One second. Yeah, I think we can probably do it there. So this actually gets called for both the MCI2S0 and PCM2. But that's because the front end one also calls that. So the front end calls that. And the is this really necessary? I think opening the front end is opposed to. But anyway, we get the substream, so. Yeah, so we can check for is speakers, and then if the direction, which hopefully we can get from the substream. Yeah, stream direction is there. So I can probably just check for that if it's speakers. And then I just need to hack the backend. If substream stream what's the right thing? Capture. And then I check for his speakers in here. Then we also skip that. And then the trick is we need to change the DAI. So does that get called before or after setting the thing? So if it gets called after, that's good for us. So here it sets I2S1 and so it says 1 here and that gets called afterwards. So that's kind of annoying. Yeah, it sets the DAI params and then it sets. Okay, let's recompile the changes. See if I can make sense of that. Because there's also the opposite side where if this gets called before, then when the other device is being opened, I can override the check that way. So, okay, that's compiled. Okay, BRB while that boots. Okay, back. Let's see. So. Okay, so we are. This runs before the set DAI params. So we could run the others after that. So, but now the question is, does it run before the failure point? No, it doesn't. It does call B hardware params fixup, though. It's kind of annoying. So I'm not sure this fixup thing is really the right way to do it. So maybe the better way to do it is to just... So this is called afterward. So where does that come from? Parent symmetry. So here codec DI. CPU DAI. Yes, it's that one, right? DAI hardware param, CPU DAI subs. Is that it? Where's the front end and back end ops? These are for the links, front end and back end. Let me just add a warning here. Following the sound sock stuff is pretty tricky. um, Okay. Okay, so that gets called by link hardware params, which is called right after symmetry. I don't know if we're allowed to modify params here, but if we are, I could fix it that way, I think. Link MCS1. Let's try that. Let's see if I can force the rate to 0 here. What about the fixups? Can I look at that, for example? Okay, that's how that works. Okay, so that's going to break in the opposite order when we play the speakers first, because it's going to clear the params. Though, but in that case, I think it's not even going to let it do it anyway. Oh yeah, but it would because of the mismatch, yeah. But let's just try this one at least. But basically, the check here would be that if the thing is running, then we need to check that the rate matches. Otherwise, if it's not running, we just zero it out. And I know I can do that in here somewhere. Yeah, so I can check the runtime state. Yeah, there's... okay, let's see. Didn't fail, at least. Hey! It worked. But it says sample rate 0 because... reasons. Also, that NAND doesn't... well, sample rate 0 would break, yeah. So how do I get this to report the right sample rate? I need to set it for the PCM when the other one comes in. I'm not sure if this really needs to be here, though. Because the backend is going to get called anyway. So, yeah, basically I need to check the substring there. So in this case, we can clear this and it'll just pretend the rate is the one we set because it's only clashing at the back end. Actually, does the other way around work? Let's look at this first. It does. So the rate never got set in that case. Actually, something went wrong there. Whoops. No, so it just crashed there. That's an unexpected fail. Wait, I think this is just something dumb. I think we need to clean up some of that. Yeah, I think there's just a bug there with like the second time you use it. So I want to know what forces the range that this gets, because that stopped working and I need that to work. I saw that earlier. What was the hardware param stuff? I saw that earlier. What was the hardware params? There's a is it an apply symmetry? I think it's an apply symmetry, yeah. Yeah, that. So symmetry forces. Okay, so that gets called with apply symmetry. Okay, let's get rid of the warnings here. Actually, that one's fine. Look from the top. Yeah, so that gets called first. But that's just the first is the test one, and then it's the one in Mac. Okay, so yeah, that test one we don't care about. And then after that, set the param sets rate equals 0, which makes sense because that's what we did there. Then again, rate 0. So then it sets rate 44,100. It calls that, and then it does set it to 44,100 for the tasks and the I2 as 0. And then 1. No idea what this is about. How? What? I have no idea what that's about. Okay, I'm gonna get rid of the warns there, and run it again because I'm just getting confused with the output right now. Too much stuff on that log. Let's clear that screen. I'm trying to make the speaker safety thing work. It's not really a problem so much as like I don't know, engineering around the ALSA stack. Because we're doing a thing that nobody's done before, and you know. Okay, so in this direction, you run that, and then speaker test. Then I can kill that. So in the other direction, run this first. Then run that. Okay, that errored out. But it didn't get the rate initially. Okay, so how did that work? Yeah, so we got a rate symmetry mismatch. Yep, the sample rate mismatch between the PCMs. So I found a hack where I can modify the params in one of the callbacks in the Mac Audio driver, and 0 means don't check as far as the symmetry stuff goes. So that's pretty much what I want. And actually, I think I don't need the. I think I don't need that thing anymore. But now I'm not getting the feedback on device open. Unless that's because I set that. Or is it because I said skips rate here somewhere? Ah, yes, skips rate when we. Oh, it's probably that dummy DAI. Okay, let's get rid of that code path because it's doing more than what I want. No, that cost thing is something weird. I don't know what that is, but it might have been corruption because I had a different issue that time I ran that. So if I see it again, I'll worry. Otherwise, I won't. Because there was some ref counting snafu, like use that for free. Okay. Okay, so now in this direction, if I run the speaker test first, and then... Nope, still doesn't do that. It's noticing the mismatch. The thing is, before the patches, the rate here was already getting set to 44,100. So that would be a nice thing. The idea is that, like, if the Rust thing runs first, it can pick whatever rate it wants. If the other side runs first, it constrains the Rust speaker safety daemon when it opens the device, and which is fine. But I don't know why this is not getting reported. Did I do anything in the fixup in the end? No, I think I just print stuff. Yeah, so that doesn't get called. It gets called here. I think that apply symmetry isn't working. Oh, wait. It's because I said hardware parents fixup, isn't it? That's bypassing part of the... Because the backend is shared, not the front end. Okay, then that's probably going to work now. Okay. Let's drop the fixup thing. And then on the Rust side, I can just make it take the lowest rate in the supported range, which is going to be either 8,000 if the Rust daemon is running first, or the actual rate otherwise. Okay, I think this might actually work. Yes, 44,100. Okay. So now, update symmetry. Yeah, so in the Rust side, to make that actually work, because this is how I'm intending it to work. What? Oh, wrong place. Yeah, so we're just going to set this to 0, and then it'll just take the lowest one. And that also will make it very obvious if we are actually constraining the hardware, because speaker test will, play at 8 kilohertz, which... it's just that for some reason, I don't actually know why it does this, but this has if that hook exists, it doesn't run this part. And this is the thing that actually constrains the PCM sample rate to the backend sample rate that is currently running. So, so that actually is going to constrain the backend if necessary, and then I need to actually check that in here so we don't set the front end to 0, because right now the rest stuff is going to be getting sample rate 0. So now that the remaining part is getting the sample rate feedback into the Rust side. And I think I can just do it by setting the rate on the PCM, which I can probably do in Mac Audio. Actually, yeah, I can just do this. And that's going to work from the back end, because it's the same DAI. So then that will avoid overriding the backend rate when we actually, wait, is that RTD to CPU? I still don't understand the object relationships here. So what we're actually getting here, it's called PCM and I2S. Yeah, so we get these for both the PCMs and the, yeah. So for the back end, it should be fine to do this. And then, so I would want to get the backend here somehow. Yeah, so I need to get the other front end here. How do I do that? What is that PCM runtime anyway? What's the object structure here? That'd be really nice to understand, because right now I don't get it. Okay, so there's backends and frontends. Each one's a runtime. Okay, so yeah, so I need a link between PCM1 and PCM2 somehow. How do I do that? Did MCA have some hacks around that? There was some place where it was doing stuff like that. Because one way we do go to the backend or one of the backends and see if it has a rate, and if it does, then we set that here, and then in the other direction, we set the front end rate when the other one, yeah. So how do we go from backend to front end? Okay, so okay. After this patch, we'll be able to use speaker safely in M1 Max. I mean, when it's all done, yes. There's a lot of things that need to happen first. I need to finish this, and I need to also add the actual kernel side safeties, and then I need to actually implement the settings for all the machines, and like, y'all know this is taking a long time because it's complicated, right? Like, no one has ever done this on Linux ever before, and you have to change like every single part of the stack to make this work. Okay, so CPU DAI rate. So this is saying we need to get the rate, and we want to set that into the sense PCM. So I need to get the front end. How do I get the front end from here? I got a back end. Go to the runtime data. And the CPU, so the CPU DAI in this case is the MCA thing. Yes, I think this is what we want. So we look for all the capture front ends. So then we get the DPCM out, which is actually what we want. That ties the back end and the front end. So now how do I set the rate on that? I can just set rate on this, but I don't know if that's going to get returned from the harder parm stuff. I don't know if that's correct, because that might just create the conflicts later, because it's going to check it. No, it doesn't check it against the front end. Only the back end checks the conflicts. And the front end, whenever that gets close, it's going to do that anyway. Okay, so maybe that's okay. And then we have the other option for each backend. Okay, so how does the hardware params get work? If I just run trace on that, and that's with the minimums thing. So if I do trace on that, and now it's going to say that for 4,000, sample rate 0. Okay, so it doesn't actually get the sample rate. So maybe we can't actually get the sample rate this way. So the other way around should work, though, if I do that first. And then it picks up 44,100. Oh, wait, no. Why is it 0 now? Because I overrode it here? Okay, so the sample rate here. Let's see, what did the actually this do? So this ran hardware refine, then hardware params, software params. So in this case, what this is getting for the sample rate is get rate. Oh, because yeah, because we only load the params once. Okay. That might just work now. Okay, still 0, but the no, still 0. Okay. So is it actually calling it every time now? No. Okay. So hardware params current. That okay, that's not actually querying the hardware. So we can't actually inform user space like that. So that's not useful then. Let's see, what are the actual UAPIs we have? Can we get stuff? Otherwise, I could just use a mixer element to have like the speaker sample rate in there, but that's a little bit ugly. We hardware params. This might not be designed to do that, unless there's a status thing I can use. Okay, let me look at PCM. Yeah, so this is always just setting them. It's never... So what about refine? Where is that? It's in PCM native or... Okay. So there's a hardware constraints. Again, the constraints just come from rate min and rate max in the PCM hardware after the open. So that means we probably can't actually do anything because it's not going to get updated. Yeah, okay, so that doesn't work. So mixer element, I guess. We already had one that I'm not using the speaker active thing, so I can probably do that. Use that and change it into like a sample rate thing. Speakers up indicator, yeah, that. Let's go to speaker sample rate. So that's an integer. Count 1, min 0, max that. And it's read only, and the get. Call it speaker sample rate. And then here in speaker streaming, we just need to change it to the actual sample rate. So in hardware free, set it to 0. And then instead of MB prepare, I actually want that in the B hardware params. Which means I can drop that. Yeah, so we can just do it here. Yeah, that should work. That's not too crazy. And then instead of true, set the actual rate. So I can recompile that. And then in the Rust side here, I need to create the control. So then this can just stay there, but we don't care about printing the sample rate because we're going to be overwriting that anyway. And then I need to get the control here. Oh, it's not even, I don't even have that here. Types lm new let me just speaker sample rate. Oh, that broke a lot. Hold on. Yep, so we can then drop the fixup and the prepare. We don't need that anymore. And props in 613. Oh, actually, that's not even used anymore. So, get something here. And then on the Rust side, I need a new elements because sample rate card is not card. I need to refactor this code. It's a little bit, it's a bit of a mess. Globals, config, control. Oh, that's the card, okay. And that's an integer. And then the element PDV, CTL. Oh, actually, I don't even need, it's just a name and a value then. Okay. Yeah. TL, and you can just drop this then. Not make it public. And then the value, need to do a get integer. Make that mutable. And then here we can just drop it as 0 anyway. Okay. Sample rate. Oh, wait. Not that. It's just helpers VDV. Okay, that compiled. So let's reboot with the new stuff. And I'll be right back. Okay, back. So, let's see. Is it going to work? Can we get something? Well, first of all, okay. Probably would be nice to not have that be a literal like slider there. But I mean, it doesn't really matter. It's read-only anyway. Okay. So if I do speaker test, yeah, I think that's just they're trying to be smart. But so if I do a mixer, C controls C0. C get. Yeah, that. So if I run that, get 44,100, and if I set it to 4,800, you get 4,800. So that's all working as intended. 8,000 doesn't work. Not supported. 24. No, I think we only support starting 44,100. Yeah, I think we're going to support some of them anyway. Do we support 96? Yeah. So that's all working as intended. So now the cargo run. Cannot read element value. Okay. Enoent. Name's fine. Yeah, doing floating point and just DSP in general in the kernel is not going to fly, so. Speaker sample rate, why is that not working? This capability is volume. That's not exactly what I want. No, so the idea is that if the daemon gets killed, the kernel will limit the volume to a safe volume. So there's going to be like a watchdog thing going on. which is a whole nother story, which is probably not going to happen today. I don't know. We'll see. But at least if I get this running today, I'm hoping I can get it to the point where it will work, right? Like I can run the daemon and it's not going to be safe against failures, but it will do the right thing as long as it's running. Which is going to mean the sample thing has to work. Why is this deciding not to work? Yeah, well, I don't know why it says the thing doesn't exist. First of all, let's do that once at the beginning, so it's easier to see when it fails. No end. Oh, wait. Okay, no. There. I hate ALSA lib. Set ID. Set name. Okay, then I probably want to use this lm thing after all, because yeah. Pub. Okay, hold on. Let's clean this up. This is kind of a mess right now. Pub fn read self. Actually, just say read integer. Yeah, read int i32, and then basically it will be get integer. Read EV. So basically, what helpers read EV self read card. Yeah, we don't store card, so we do need card here. Read the value, element name. let me just say self.val get integer 0, expect, could not read. Self.name. Do I not have the like Rust formatting stuff here? I guess I don't. Yeah. And it's no and there. lm equals types lem new sense, and the card is the CTL, and then the lm type is an integer. Uh, 349. Did I miss? Oh, damn it. Okay, so now we get the lm, and then I can just say it read int. So val self name. That again. String. And then read EV here. Oh, because I need it needs to be that. Okay. Hey, 44100. And 4800. Whoops. So it got locked up. On the first. Yeah, okay, so the issue is that here in the back end, are those prints? Set DAI params. That gets set to 0 only here when the DAI is not active. And that, where? copy and include. No. It's in DI, okay. Yeah, so if it has any active streams, it considers it active and it doesn't clean it up. So one thing I want to know is whether the clocks are getting cleaned up. So if let's try that again just in case. So let's run it at 48K now. Yeah, it does kill the clock even if this is running. So that part is working fine. It's just that it thinks the... Yeah. So we need to clean that up. In hardware free. Oh, we do have V hardware free. So if it's speakers, yeah, then we just need to set the DAI right there. The rate to 0. I just realized, how does this work with the... when you have different channels selections? I'm not sure how that's supposed to work. Maybe it doesn't. Okay, so that should fix the not being able to change the sample rate issue. And then why did that say... Oh, that was when it was closing, I guess. You get a couple more... Yeah, and then you got the EIO at the end. Which means we want this part to keep the sample rate. So I want to know if the first one runs with the right sample rate at least. I think it does. Because I would never want a 0 to happen there. Yeah, it does. I think this is safe because we read some data. The sample rate obviously has to be set as the parameter. And it's going to get unset early, but that's fine. It'll just keep the previous one. And I mean, there's a race here, but we're sort of making the assumption that you're not going to be switching sample rates at a ridiculous rate. So I think that's not going to be a big issue. Okay. Okay. And then the next thing I need in the model is the like cooldown handling. And Povik had the formulas for that somewhere. Although not having that just means that it won't automatically cool down when it'll think the speakers are still hot after not being used for a while, but that's not a bad thing. It's just, suboptimal. So, and then, so after this, I need to do all the, like watchdog type stuff. I first need to fix the EIO that happens when it times out. Actually, if it returned an E timed out or something, that would be okay. As long as the daemon knows that it's a timeout and not an actual IO error. But if it's an IO error, we need it to panic. So, yeah. So let's look at that. SSH, not SSH, what am I doing? And then mount it again. Cargo run. Speaker test 44100. Yep. 48. Nope, did not work. Oh, because the amps. The amps are also getting set. The amps are also getting set. Yeah, so this checks like all the CPUs and all the codecs. So is this clearing the codecs when we shut down? Yeah, it does it for everything. I think that should work then. And I'm going to do some cleanup because there's a bunch of junk I don't, like that. Not using anymore. And that is also gone. And that I don't need anymore. All this is fine though. And I missed some. Yeah, so that goes away. No runtime and none of that. Yeah, all that went away. Is the codec driver responsible for speaker or mic too? Mic is a different driver. Povic's working on that. Mic is complicated. It goes through like there's a coprocessor involved and stuff. I don't know much about the mic story. But that's also why that doesn't work anymore, because it's a totally different thing. $44,100. Yep. 48. Yay, okay. Cool. Okay, sample rate switching works. Now I just need to fix this stupid timeout thing. I don't know where that comes from. But I think that's a good stopping point when I get that fixed, because that's the last thing for this to be able to function. Just missing the safety stuff. So there's got to be a timeout thing somewhere. Is that in the core, PCM native, or PCM lib? No period wake up? Is that what it is? Yeah, 10 seconds. Yeah, there's a no period wake up thing, conveniently setting that to max. Yeah, no period wake up sounds like it's going to do what we want. There's actually a wait time in this upstream. Who sets that? Ah, okay, it's a hardware param. But this is not exactly what we want. I think that's not what we want. But it's just the wait time. We can probably set that, and it should be fine. Yeah. I think I just put this in startup. But only if, yeah. What is max schedule timeout anyway? I want it to be long enough at least. Long max, yeah, okay. So do not timeout. Well, that's pretty easy if that's what it takes. Okay. Wait 10 seconds. Yep, no more timeouts. Excellent. $48K. Yep, looks like it works. The temp keeps going down because it's cooling down. It assumes it's hot at the beginning because that's the worst case. Also, the ambient temperature is assumed to be like 50 or something. So this is all deliberately conservative. It's not actually at 60 degrees. So, yeah, let's get the kernel stuff committed. And I think I don't need to do anything on the SOC side. I think I ended up just doing Mac Audio. This was just some fixes on there. Let me drop the warn and the print case. Oh, and that was on top of the debug thing. Yeah, I'll have to squash that. Who do I call this? Sends improvements. Oh, I need to check for yeah, that's wrong. I need to fix that. And that only has to happen for the sense device. And yeah, I can drop all the debugs. Yep. Because otherwise, right now, for example, it will, if I start playing and then close the capture, yeah, it goes to 0, which is not supposed to. That's an easy fix. What? And the define debug also needs to go away. Actually, what is this testing thing I did there? Oh, yeah, okay. Let's actually enable that. Let's make that a fix-up for that. And then I can rebase this on like all this stuff. And drop the debug one. And that's going to cause a conflict on the last one. Parent print K. Yeah. I don't know if this is pushed to the... Let's rename it to another thing. Sound. It's got DiviSense improvements. And I should also push the Rust side. Let's move some cleanup. Okay. Wait. Oh, right, that's on my repo. I'm not in Spain. Why do people think I'm in Spain? I'm in Japan. Anyway, so yeah, I think that's a good stopping point, because the next thing is going to be like the watchdog stuff, and that's going to be its own little thing, ordeal that is going to involve, that one's, I think, definitely going to involve ALSA core changes, because I don't think we have the hooks to be able to monitor user space like that. I mean, we could have the thing where it keeps updating and a control. We do need an unlock. We can do that in Mac Audio. We can have an unlock control, and then we can have it updated with a timestamp. That is actually not that hard. But then we also need to define the safe volume somewhere. Uh, do I want to do that now? I mean, it's not that hard. It's probably, well, the tricky thing is going to be, yeah, no, it's not hard. It's basically just creating a mixer control, and then having like a timeout, and then having that change the other mixer controls. It's just a bunch of code, basically. That is going to be a little bit annoying to write and figure everything out, because then I need to specify the amp volumes somewhere, like the safe ones, which has to come from the device tree. We don't even know how we're going to do that right now. It'll probably have to be some kind of property here that the driver can peek at. Well, this is already using per device fixups anyway, so maybe it's fine to put it here, but then we need to actually store that somewhere. So yeah, it's just a bunch of stuff, basically. Yeah, I think we're gonna do that next time, because I should start thinking of dinner anyway. It's like 7 p.m. and I'm getting hungry, so I think we'll do that next time. And I don't expect it to be a big story, because I mean that it's boring basically. It's just adding controls here, adding a function to go into safe mode and a function to go out of safe mode. Yeah. I mean, there's more sort of safety stuff I would like to do, like something where we actually monitor the process, and if it dies, we kill the volume stuff immediately, not just a control with a watchdog. And I'm not sure if we can do that though. Maybe we can. I'm not sure if we can do that. We need a hook into the control open and control close stuff, and I'm not sure if we have that. Let's take a quick look at that to see if it's going to be likely or not. So we have a sock card. The controls are on that sock card. Yeah, so that's all the names, probe, suspend, add links. And where we add the controls are this kind of stuff. Let's see what that K control thing has. USB sock. That's in control.h. So what hooks do we get on that? We get put. There's TLV stuff. Info. And this is that event stuff, but that's just for reports. Yeah, I think that would need core changes. We need a hook for like closing. So have control open here, and that does all that. Card file add. Yeah, so some control file is the actual open file. Is there a hook for file add? Probably not. Nah, I don't think we get hooks for that. Oh, but there's an owner thing. Interesting. Okay, so there is some notion of an element owner, element lock. You can lock them. So you can lock an element. Yeah, so there is so apparently there's a thing called user space controls where I guess user space can create a control type. Which is quite fun. Not exactly what I want, but oh, and look, there was a vulnerability in there. I don't get this count thing. Oh no, because that comes from user space. Okay, that's fine then. It's kind of a hack. But that's not what I want. What I would want is to actually check the owner, and when it gets dropped, to have some kind of callback. So I need like lock and unlock callbacks basically. Yeah, so I think what we're gonna have to do is add to maybe one more callback, like lock, that is used for both lock and unlock, and call that when things get locked and unlocked. And yeah, I think we're just gonna add a callback, like a lock T, and that way drivers can know when a controller is locked and unlocked. And then the protocol is going to be something like you lock the macOS driver will have policy that forbids writing to controls if they are not locked, and then the protocol is going to be something like you lock the watchdog magic control, you then write the current timestamp to it to prove that you're alive, then you lock all the speaker controls, and it's only going to let you lock the speaker controls if the watchdog thing is locked first, and then you can do whatever you want with the speaker controls. But if the watchdog expires, then you lose access to the speaker controls, and they revert to the safe state. And then you would have to like unlock them and lock them again to get access again, and then on unlock for the speaker controls, the values would be reset to the safe values. So I think that's a reasonable protocol on top of the existing sort of control model. We don't need to add any new API. We just need to add a hook so that the driver, the owner of the control, can know when it's locked and unlocked, so that the unlock operation would implicitly also happen when the user space app dies, because that goes to the unlock path. So I think that's going to work. Yeah, so this is so the safety daemon can control the volumes. So we need a safety so that nobody but the special safety daemon can control the volumes. And so we're going to invent a handshake basically that lets it do that. And yeah, I think we can use the lock mechanism to be notified when the daemon dies, so it can immediately lower the volume to the safe volumes. And yeah, it's just one callback. So that's going to be the plan for next time. please don't use this yet. It's not ready yet. It's not safe yet. It only works on one machine. We haven't even looked at the parameters for other machines. Okay. Well, I think that's a good stopping point. How many audio systems, X-based systems benefit from this? I have no idea. I don't know if there exist systems out there that are currently underpowering their speakers and could sound better with this kind of safety system and be safer. Yeah, I don't know. I know a bunch of phones do this. Android does this. And I know a bunch of, laptops sound terrible with Linux. So it's totally possible that this could benefit other laptops. But someone would have to look at that. That's why this is getting implemented mostly in the Mac audio driver. I'm just going to add the lock hook because right now we don't know of any other system that needs this. If we end up, whoever comes next that also needs this, then we get to figure out how to make it shared and, have the same protocol. Would this improve the public restriction of Linux audio? I hope so, because at least in these machines it's going to sound decent. It's going to sound better than probably any other laptop running Linux, so... All right. I'm going to log off and get some dinner. But yeah, it's getting there. The audio stuff is getting... You can technically already use this. It's just not safe because if it dies, nothing... There's no fallback. There's no watchdog. There's no safety for the safety. But when it's running right now for this machine with these configs, with this everything, for this one case, it should do what we want. Though I still need to implement the catch up when the thing has been idle for a while, but that's probably best done after I add the kernel side safeties anyway, because it has to do with the timing. And that's the other thing, is that I don't know if we want the safety daemon to pull the to poke the watchdog even when there's no data coming through, or do we want to just let the kernel sort of fall back to safe levels until the next time data comes through? Probably want to poke it anyway, because that way the... Well, no, that's not clear, yeah. So if we poke it anyway and then somehow the data is dead, but the speaker's actually running, then it wouldn't be safe. So maybe we actually just want the kernel to... to reset the safe levels then. But then we just need to make sure that the daemon is fast enough, because otherwise when you start streaming, the volume will be very low and then increase and might not be very nice. Anyway, we can find out when we implement this. Okay. Calling it a day. See y'all.